Generics allow for runtime polymorphic containers through a single instantiation of a generic container. In Java, all the objects are references and all references are the same size and so can be handled by the bytecode. However, a necessary implication of having only instantiation of bytecode is type erasure. You can't tell which class the container was instantiated with. This wouldn't work in C++ because of a fundamentally different object model where objects are not always references. There is a big difference between them. In C++, you don't have to specify a class or an interface for the generic type. That's why you can create truly generic functions and classes with a caveat of a looser typing. Here you can see it. The method above adds two objects of the same type and can be used for any type T that has the plus operator available. In Java, you have to specify a type if you want to call methods on the objects passed, something like this. In C++, generic functions or classes can only be defined in headers since the compiler generates different functions for different types. In C++, generic functions or classes can only be defined in headers since the compiler generates different functions for different types. So, the compilation is slower. In Java, the compilation does not have a major penalty, but Java uses a technique called erasure where the generic type is erased at runtime. Templates are more powerful than generics. The former is effectively another language embedded within C++. Another advantage of C++ templates is specialization. Now, if you call sum with pointers, the second method will be called. If you call sum with non-pointer objects, the first method will be called. And if you call sum with special objects, the third will be called. This is not possible in Java. Think of C++ templates as a really good macro system and Java generics as a tool for automatically generating typecasts. Here can see some differences between generics and templates in chart format. First, in C++, classes and functions can be templated, but in Java, classes and methods can be generalized. Java tends to focus on the definition of the generic, that is, the validity of the generic definition is checked by only considering the code in the generic. If parameters are not properly considered, certain actions cannot be performed on them. The actual type it is eventually invoked with is not considered. C++ is the opposite. Only minimal verification is done on the template itself, which really only needs to be passable to be considered valid. The actual correctness of the definition is done at the place in which the template is used. Java allows bounding of arguments. It really does need to be stressed that template invocations with different arguments really are different types. They don't even share static members. In Java, this is not the case. Like this can differentiate C++ templates and Java generics as above shown. We hope the information we have provided to you is sufficient to get a decision which language is best and suitable to you. Thank you.